Hey everyone, we're looking here at the graph that we made in the last video. This is from the evidence problem, target number one, problem number one. Um, I showed you in the last video how to use graphical analysis to go ahead and get this graph and this information. We have our salt and our sugar and their effects on the freezing point listed right here. So I'm going to start writing on this. Obviously, you're not using a computer setup the way I am, so you're welcome to do this on a separate piece of paper. You're welcome to do this in a Google Doc. I've done this whole thing by hand. Although I will say I've had some students do this by hand and it was really difficult to read their graphs. So I would highly recommend doing graphical analysis if you can. So first off, let's just make sure we know what we're talking about here. The blue here is the sugar. Well, Surgrar. Sorry, guys. And the red guy over here is the salt. So we have sugar and we have salt. And what's happening is as we are adding sugar and salt to this water, we see that the point at which they freeze is changing. And that's a really important thing for us to be able to understand is what we're seeing here. The more sugar that I add, the freezing point seems to be changing. The freezing point seems to be dropping. And immediately I see it seems to be doing it more with the salt than with the sugar. So what I'm going to do is I'm going to go ahead and create some linear models. And by linear models, I mean equations. Now, we could do this all by hand with calculators and whatnot, but look, I got all this information right here. It's going to be a lot better. So I'm going to go ahead and use that. So let's zoom in here. Let's look at this information and see if we can get equations. So we know that the general format for any linear equation is y is equal to mx plus b. And look, they give us m's and b's right here. Beautiful. So that's what we're going to use. We're going to use these numbers. Now, the problem we have, though, is um, we need to actually figure out what the y and the x are as well. Remember, I don't want you to write y or x. So what I'm going to do here is I'm just going to say y. Well, what do we have on the y-axis? We have freezing point. So freezing point will be equal to the value for m for the sugar is negative 0.055. I'm going to round that to negative 0.006, negative 0.006. I'd be fine if you kept it at 0.0055 or 543 or whatever. But just for the sake of making things a little bit simpler, I'm going to round it to 0.6. I do need units on this. So what's the units going to be? Now this is a slope. Slope is always a comparison between what's happening on the y-axis and what's happening on the x-axis. So we need units for both the y-axis and the x-axis in our slope. So the y-axis has units of degrees Celsius, and the x-axis has units of grams. So here's what that means is for every gram of sugar that I'm adding, my temperature of freezing is dropping by 0.006 Celsius. All right, y equals m, we got the m dealt with, times x. X is just our mass added, plus b. Now, they tell us that b's negative 0.014. I will let you know, I meant it to be 0. So I might just drop it, but you can go ahead and throw it in there, I guess. Oh, sorry, no, b here is 0.009. I'm running out of room. How do I fix that? All right, 1 second. Advantages, right? All right, so I'm going to go ahead and add in this y-intercept. It's a positive 0.00. I'm going to just round that to 1 grams. All right. Next, let's go ahead and get the equation For the salt will be pretty similar. It's still just going to be freezing point. But we have a different slope. Now our slope is negative 0.06. We still used rise over run, so that's degrees Celsius over grams times the mass that we added, plus our new y-intercept, which is now negative 0.01. All right, so we have our equations. Now this is what I want to see. Now let me point out some really important things here. I do not want to see y's or x's. I want to see the titles of the axes. I do not want to see numbers without units. Well, for the most part, there are some situations where it's appropriate, but this is not one of them. This 0.006, I need to know that that's degrees Celsius over grams. This 0.06, I need to know that it's degrees Celsius over grams. This negative 0.01, I need to know that that's grams. And I'm just getting those units from our axes. Remember, the slope is always the units for the rise divided by the units for the run, and the intercept is always just the units of the y-axis. I expect you to be able to give me these equations. Absolutely. This is something I expect you to be able to do. Next, I want you to be able to interpret the y-intercept, or sorry, the slope and the y-intercept. So let's do that real quickly. The interpretation of these is actually not too bad. The best way to interpret a slope, and we've done this before, is using a for every statement. So here's what I'm going to say is for every, oops, if I can draw a y. Sorry guys, I still have not, my handwriting's still not very good. For every gram of sugar added, the freezing point drops by 0.006 degrees Celsius. This is a for every statement. It's always for every what's on the bottom. There is some change of what's on the top. This should not be the first time you've seen that. We've done this a lot. This is how I want your interpretation of the slope pretty much every single time. I do have some students who say the top number first. For every 0.006 degrees Celsius you want to drop it, you have to add 1 gram. That's not wrong. I just don't prefer it. I prefer for every 1 gram of sugar added, it's going to drop by by 0.006 Celsius. Now, notice I'm saying it's dropping. That's from the negative. If that negative were not here, we'd be saying growing, shrinking, adding, going up, going down, some sort of indication. So I do need to see that the temperature is changing and it's going down. That's important to me. All right, second one. I'm going to cheat. Oops. Can I cheat? Oh, no, I can't. Aha, I can. And then we could even recolor it. Sorry, I'm having fun. So the other, oops, why is that not working? Aha, I'll make it red. The other one is almost the exact same. The only difference is that for every gram we're getting, we actually are getting a different amount of temperature change. Now every gram doesn't result in a 0.006. Now every gram results in just a 0.6. So I'm actually going to erase this real fast and mess with my numbers here. Because, sorry, I don't know if you caught it. I just copied and pasted this because handwriting is so hard on this thing. Um, but now we would interpret the slope as saying for every gram of sugar added, oh, we're not doing sugar anymore, we're doing salt, 1 second. For every gram of salt added, the freezing point drops by 0.06. So let's look at this, what this means. Sugar seems to be a lot more effective um, than, a lot less effective than salt at changing the boiling point or freezing point. Salt seems to have a 10 times larger effect. And we can see this a few ways. So you can see it by just looking at the slope, but even if you just look at like these two lines, so let's just pick these two lines, adding this many grams, which is 20 grams, adding 20 grams of sugar doesn't really do much to my freezing point. But look what adding 20 grams of salt does. It changes the freezing point a bunch. In fact, it seems to change it about 10 times as much. That's what the meaning of this slope here is. I would expect you to be able to read that. I'd expect you to be able to describe that using a for every statement. I'd expect you to be able to compare that and go, yeah, look, the salt is so much better at changing the freezing point. All right, y-intercepts. What does this y-intercept mean? I don't know. Those are really tiny. Remember, I'm talking about adding and subtracting whole grams. Well, these are hundredths of grams. So I don't think that actually means anything. So this would be like, you'd think of the starting number of grams for both of these. But in truth, if you actually look at our data, the starting number was actually 0. But you know what? 0.01 grams is pretty close to 0, so I'm not surprised that our computer, gave us something really close to 0, but not exactly 0. It's doing its best it can with the calculation. So yeah, long story short, the y-intercept here would mean however many grams we would expect, or when we've added no grams, what's the boiling point? Oh my gosh, guys, I just realized that. Did you see the mistake I made? Did you see the mistake I made? Oh my goodness. See, you gotta catch my mistakes. See, I make them too. This should not be grams. All right, why not? Because the y-intercept is on the y-axis, and you always have to match the units of your y-axis. Oh my goodness. So this is degrees Celsius. And it's not the starting number of grams, it's the normal freezing point. With nothing added. My goodness, see? Even I make mistakes. Like, you guys knew that already though. All right, the video is getting long, so I'll cut it off short, but let me summarize. I need you to be able to look at data. I need you to be able to enter that data into graphical analysis or plot it by hand. After you've plotted it by hand, I would expect you to be able to create some sort of linear equation. I expect you to write out that linear equation similar to what I have here. Please use variable names. Don't use y and x. Please do not have any numbers that don't have any units. They all need to have units. Feel free to let graphical analysis do the numbers for you, but remember what this is. It's a comparison between when I change the x value, when I grow the whatever's on the x, when I grow the mass, how does my y value change? How does it shrink? How does it grow? And we see here that growing the amount of salt that you added seems to have a larger effect than putting in the amount of adding sugar. All right, we'll call this good for the day. Please do let me know if you have any questions. I will also be posting this on Classroom, just the key. Yeah, don't hesitate to ask. Drop by the Discord, say hi. I've only heard from a couple of you on Discord, and half of it's just Danny Actually, no, Danny, you weren't on Discord. Danny was on saying annoying things on Classroom. I love you, Danny. See you guys.